So other than moving up and down, we can also reflect our graphs, and that is if you have a negative leading coefficient. So here, let's see, we have two ways that we can reflect. We can reflect across the x-axis, and that's if the negative is in front of the x value. So it's like a coefficient of x. And then if you reflect across the y-axis, that is if you have the x and the negative grouped together. So it really just depends where's the negative. So if you want kind of a concrete way to decipher these, this would be not in parentheses. This one, the negative, so let's say negative, not in parentheses here, negative is in parentheses. So looking at an example of one that we're very familiar with, our parabola, it just the difference is opening up or opening down. So notice how with the negative not being in parentheses, then this negative is not, and let's say again, negative, not in parentheses. So reflect, if you want to think about the x-axis as like up and down, you can think about it that way, which is the x-axis, because when you go across the x-axis, the x-axis runs across, so reflecting it would move it up or down. And then here's another example. This time it's a shifted graph, but that's okay. So in our red graph, we have the absolute value of x plus 1, and that's our red function here. So if we throw this negative, now notice it's outside of the parentheses again, so we're going to flip up and down, and then that gives us what we have in blue. Now an example of shifting with the y-axis, let's go ahead and do an example of that. So let's actually start right here. So here we have our x squared parent function, and then we have the negative on the outside of the parentheses. So what would happen, let's say if we do g of x, and we put the negative in the parentheses. So that means when the negative is in the parentheses, so if the negative is in parentheses, then instead of reflecting up and down, we reflect side to side, which is across the y-axis. Now with the parabola, because it's already symmetric across the y-axis, if I flip-flop these two things, they're going to just be like a mirror image of each other. So this is the same. This function is equivalent to the parent function because this function is already symmetric across the y-axis. So when I flip it across the y-axis, it does not change. So let's look at one that's not symmetric across the y-axis. So let's do that x to the third that we did in the first example, since we kind of already have a base of what that's going to look like. So our x to the third, remember we had points. I'm just going to kind of estimate. This is what our points looked like. So this would be, we'll go ahead and label f of x equals x to the third. Okay. So let's flip this. If we do f of x equals negative, and I'm going to put that negative in parentheses, x to the third. What that's going to do now is it's going to move everything from the left side of the graph over to the right side, and it's going to move everything from the right side over to the left side. The origin is going to stay the same. So I'm going to move, my origin is going to stay blue, and then I'm going to move my positive point from at the top here, and I'm going to move it over. I'm going to move my 1 over to the negative side, and then I'm going to move my negative 1 over to the positive side. So notice I'm just like flip-flopping everything side to side, left and right. So then here's a reflection across the y-axis. So there's a difference because that one's not already symmetric. What about if you flip-flop this one across the x-axis? Now I'm going to draw a separate graph on this, otherwise it's going to get too messy. So again, let's go ahead and plot our original parent function in red. And again, this is just a sketch here, but we graphed it before, so we kind of know what it should look like. Okay, so this is f of x equals x to the third. Now, what if I just throw a negative out in front? So what if instead of the negative being in parentheses, I just do negative x to the third for my f of x. What that's going to do, I'm going to write that a little bit neater, sorry. So that's going to move everything up and down. Okay. So I'm going to move down, I'm going to move this one up, I'm going to move this one down, and move this bottom one up. And then I'm going to go in the middle. So in this case, those two are equivalent to each other. So there are equivalencies. Notice my blue graph here and my purple graph on the other side are the same. So just depending on what the parent function looks like, how they reflect might either look similar or they might look different. And that just depends on, like I said, what your parent function looks like. All right, so writing equations from graphs. The graph of the function f of x equals x to the fourth is shown. So x to the fourth, notice, kind of looks like an x squared, except it's more of like a stretched out u at the bottom. So this bottom part is a little bit longer than if we just had an x squared. But there's what the parent function looks like. So we're going to write the equation of the function based off of how it changes. So if I just observe how this letter a changes from the parent function up in the corner there, is I notice that this one is reflected down. And that means I'm going to have a parenthesis outside, or sorry, a negative on the outside of the parentheses. And it's shifted, instead of being down here at 0, 0, now it's up here at a positive 2. So it's shifted up 2. And that looks like it's the only changes that are made there. So if I want to write my equation, I know this is x to the fourth. So I want to take that, I want to show that it's reflected down and that it's shifted up 2. So to show that it's reflected down, we'll go ahead and we'll call this one h of x equals, oh, no, this one is g of x. Sorry, the next one's h of x. The picture tells me it is g of x. So g of x equals, reflected means I'm going to have a negative in front of my x to the fourth, and my up 2 means I'm going to just have a plus 2 at the end. So my negative is my reflected down, my positive 2 is moving it up 2. And there's my equation then for that graph and how it is moved. So then if we look at letter B, again, it's reflected and it's reflected down. So that's going to be the same with that negative. And then this time it's shifted to the right 3, 1, 2, 3. So when we do that, and we're going to use h of x on this one, we'll have h of x equals the negative reflecting down. So that will be my negative out front. And then right 3 means that inside the parentheses, I'm going to have x, and I'm going to do the opposite. So I'm going to do minus 3, and then to the fourth power. So remember, whenever you would move left or right and you have to put anything inside parentheses, it's always the opposite of what you're given.